Hello, this is Siddharth. Welcome to Deep Realm channel. Today's topic, I just want to go through another paper which I am trying to have it every weekly basis. This talks about specific optimization method to compute those LLMs to train it efficiently without labeled data. And the particular name they have given for this is called TAO. That means it is a test time adaptive optimization. Let's dive into it. What is this about and how you can gain some knowledge from it? Okay. Now, the basic to the introduction to the tab, right? You can call it as TAO. I'll just call it as tab for the quickly reference. So for this, let's take a common example of a smartphone's autocorrect feature, right? Since you know that autocorrect feature, what you have, it learns from your typing habits over time. Initially, it might make incorrect suggestions, but as it adapts to your unique vocabulary and typing style, its predictions become more accurate, right? That is one of the feature they are trying to get involved in this tab. So similarly, what happens in tab? This tab enables these AI models to adapt and improve their performance based on the data they encounter during the operation without requiring this pre-labeled dataset. As you already know, because for every LLM training model, you need to have some input mostly and also the output that should be labeled. What does it mean? The main agenda for this is we need to train a model without having that label data. That's what it all this paper talks about. And this is very new. I think this came last week or some few days back, right? Let's try to understand its concepts. So similarly, training a particular data without having the labeled data. You can train with the input. It learns as the time in the process of training using this reinforcement, which I'll go in the next step, usually tries to learn from the input data and efficiently optimize itself, right? And now the next topic, the basic topic is the test time compute. For this, I come up with an example. Let's go with this GPS navigation system, right? So in the GPS navigation system, usually it not only provides you the directions or better pathways, right? But also it learns from your real-time traffic patterns, right? That's the main thing. As you drive into it, it analyzes your current traffic and adjusts your routes dynamically to ensure the fastest travel time, right? Now let's inherit this example in tab. In tab also, what it does is it has this test time compute, which refers to utilization of these computational resources during the model operation, right? To refine its performance based on the whatever the incoming data that it reaches up to. And the other main topic in this tab is reinforcement learning integration. For this, we can come up with an example called a video game character. Think of any of your favorite video game character. If it has to learn what are the obstacles, it has to face through those obstacles first so that it can learn effectively as it plays. Each time the character fails when there is any obstacle, right, it can receive a feedback, adjust its strategy and improves the subsequent attempts, right? For this, let's see on this tab side. Tab also employs this particular reinforcement learning strategy by allowing these AI models to learn from their success and mistakes during this real world task and enhancing their accuracy over time. This is what it happens using the reinforcement, right? And there is another concept here which is called Databricks reward model. For this, you can come up with any example, which is an online streaming service. Any of the streaming services which provides the better movies and best movies like that, right? Usually this online streaming service recommends movie based on this user preferences. And it uses a system to predict which a movie a user will enjoy and adjust its recommendations based on the user interactions, right? Based on how you see the movie and based on your recommendations, right? They will provide the recommendations to you and what watch time you have watched and everything with a lot of parameters. This particular Databricks reward model, which is called DBRM, functions similarly by predicting the human preferences and guiding that specific AI model to produce that output which aligns with those preferences, thereby improving this model relevance and also this accuracy. That is one of the concept. And what is the efficiency with the unlabeled data? This concept also, then for this, let's have an example, a chef who learns to cook, right? So every time chef has to learn basically according to the new dish, if he have to cook a new dish by tasting and adjusting this ingredients, right? Without following a written recipe, without seeing any particular predefined instructions how to cook it, right? Chef learns by itself a new dish by tasting and adjustments, right? Usually if he has some spicy, he want to reduce it spicy, something like that. Similarly, TAO also enables its AI models improving their performance by learning from their data itself. They process during this operation and eliminating this need of extensive label dataset. So what it is trying to do it is, whatever the particular training it happens in the test time, it uses those computational resources to train efficiently, right? In that, what it does, it improve their performance. Whatever the unlabeled data they have get it, they usually process it during this operation and try to eliminate this extensive label data set, right? And the main purpose of one of the processes, we should also remember the cost effective model, right? For this, you can think about a better example, which is called a car's adaptive cruise control system, right? It becomes more efficient, right, as it learns from various driving conditions without requiring a mechanic to manually adjust its settings. TAO reduces the need for the manual fine tuning of the models, which leads to reduce the cost savings and also in both time and also these resources. This is one of the most advantageous thing what happens when you develop this kind of models, right? The basic thing is the cost effective. And the other major concept also you should think about is the scalability, right? The scalability. And what is this here? Consider an example of language translation app, right? Usually in the beginning, you may see the translation app providing some wrong results, right? But how it becomes accurate as more people uses it again and again with several instructions, several input parameters, right? With the large inputs, it trains and it learns by itself from the large diverse instructions, which doesn't need any additional programming. So when the user inputs the language, if there's any issue, it will try to learn by itself, and whatever the user gives that input, right, without needing any additional thing or any programming or any coding. So the tab also utilizes this kind of concepts, which allows these AI models to scale their learning process across various tasks and applications, adapting the data seamlessly. That is one of the things. So these are the one of the particular structure, or you can say a pillar of this concepts you need to understand before you try to understand what is this pathway, how it works, right? Now the next thing I just want to go here before you see how does TAO work, right? They have this benchmark, right? Using this particular tab, they have trained this Llama model with 73.370 billion parameters, and also Llama 3.1 version with 8 billion parameters. If you see here specifically the red color one, which is being trained with no labels, right? The main purpose of this is taking the input as many input parameters or as many input instructions or input data you need it, you have used it without any label data. If you see this red color mark here, you see it crossed in most of the scenarios. In the finance benchmark, DB enterprise arena, and also in the bird SQL, you can see there is an improvement by training in this way without showing any labels and training them in the test time compute, right? It learns from its input and it uses this reinforcement learning again on top of it, and it corrects accordingly or adjusts accordingly, right? And the other major one you can see here is with 3.1 version with 8 billion parameters also, you see a little bit of improvement, but not for all the arenas, right? It works better for Llama 3.18 billion without labels and Llama FT with labels. But if you see the other ones, for the DB Enterprise Arena and Bird SQL, you see somewhat little bit low performance, but still it had maintained better performance going into this new path instead of the traditional route, right? This is a major thing. And usually, how does this TAO work, right? The key idea in this tab is to use this test time compute, right, to have this model explore that particular plausible responses for a task, then uses this reinforcement learning on top of it, right, to update an LLM based on these responses, right? So if you see here, the first basic thing is, it's a common sense. The basic one is how you provide the inputs. And please remember, the inputs, whatever you are providing, you are not labeling any data, right? You're just providing it, and it has some responses based on your input, right? And for each response it will try to score it. Then this reinforcement learning training will take part its place based on the highest scoring. It will assign that particular response as the label, as a kind of analogy, as a label data. So when the user gives with the new input similar to that, it will provide a near time, real time, near good data based on this scores, right? And that is how you train your LLM. And this is a continuous improvement. So what happens once you have this particular whole model has been trained, you have been produced to the production, and the people will have lot of input instructions. So what happens is those input instructions will be again used to train that response scoring. And also once you have scoring, you'll have that particular training method or strategy of reinforcement learning to correct it accordingly and make that model better. This is how it will usually work. And we have technically, there are several LLMs. You can manually tune those particular things, right? Let's have the comparison with different LLM tuning methods. This specifically talking about the methods, right? The first thing, let's they have divided into three classes: the data required, and the quality, how the quality is it, and what is the cost for it. If I alone go with only the prompting, you don't need the data. Usually you'll have a list of a series of text, and you'll provide a large text or whatever it is, right? It will generate some response, right? What is the quality of it? Usually for the small size of the data, yeah, you may have better quality. But if your instructions are too long, right, the size of prompts are which are too long and which is not supported, then you may see some issue. And usually the cost is debatable here. Usually they are saying it low, and based upon the tokens it can be high also, but usually on the high level ground the cost was low for the inference, right? And the other thing is about the other method is about fine tuning, right? You will have some input, you will have some output. Having those input output examples, you will typically train with the data to get a quality outputs, right? And the achievable quality will be very high, right? Because you have this lot of inputs and you'll be training with lot of outputs. But you should remember, the quality is also directly proportional how the output is provided by a human, because mostly the outputs, the data will be trained based on labeling it. If the output is not so good, your quality will be also not so good. And the inference cost, here it is low because you are already giving the input output and it's specifically training what it should be. So maybe the cost of it will be low. And usually the classic test time compute, I think I have read somewhere this test time compute is also being used in the DeepSeek R1 model also, something like that, and there are other models. You can later verify it, fact check it. So usually the classic ones, usually you don't need it because you are testing all this data without any input output examples. You're only training the data with an input, right? So it will be having that quality, it will increase that quality because you're training based on the logical reasoning task. And I heard this cost is also very, very high because it has to go through the several iterations to reason it properly. And the cost, okay, as I said, it will be very, very high because it has to have this long chains. Okay, step one, do this. Okay, I have reasoned from this, then go for the step two, step three. These reasons will continue continuously, and you need to also keep remembering of these tokens, right? It has to remember that whole context, what is happened previously and to the next. It has to connect to that and it has to give that particular answer. For that, the cost will be so high because of that remembering the tokens from beginning to end. Now, the strategy they specifically taught and told about in this paper was test time adaptive optimization. In this, we know the specifically only the input is provided, right? Existing LLMs use this data and no other things are required, just an input, right? And the quality is very high because they are saying this particular thing has been very much high on the enterprise task. For example, I have a document, maybe HR policies and everything for this specific company. You are just having that input loaded because based on the document, as several questions are raised. How the answer should be will trained here in the test time basis, which if I go here in the diagram, right, this whole process of training the model is done in the test time, right? So what happens, it will use a large compute power to understand that particular thing, the document or whatever it is, and it will learn how to provide the responses based on this training method, which is reinforcement learning. That's what we should remember. And the only data also what tab needs is this LLM inputs, how you are giving those prompts and everything, right? Usually that's the only thing you needed. So that's why they have tested on this particular enterprise task and they have seen a commendable high quality, right? And the cost for this, the major concept is about the cost also. It is same as that original training LLM models, which is good actually, right? And if you see this task performance using with tab, right, they have this several benchmarks, right? If you see this particular thing in this Llama with 8 billion 70 billion in chat GPT and using training with this tab, if you see before it was 71 and it was 80 without any trained data, only with the input. You see the improvement here and you also see the improvement in the bird SQL benchmark. And even for the 70 billion parameters also, for the specific task performance with the tab, right, it is also commendable actually, which is good. And if you compare with this ChatGPT 4 mini, ChatGPT 4o also, it was little bit better, right? That's what the expectation is. And sometimes this is a single task, right? Sometimes there may be a place where it has to be very intelligent and do this multitasking, like kind of a agent's concept. This specific task done by this specific agent, this specific task done by another agent, combination of this multitask, it should be very intelligent, right? And what they are proving this particular benchmark is by you can also improve this multitasking, right? You can enhance this and optimize it with tab and you can see this the benchmarks for the chat reasoning score code and everything. And if you see this for the tab, right, which you have particular this new methodology, what you're doing it, right, you see a good amount of percentage increase for each of them, right? And the only thing we see because of this code score, we can also later deep dive into why it is, what is the reason. But if you see on the all other areas, it is performing very, very well. And some of the places where for the ChatGPT 4 mini, 4003 mini, more than that, some of them it's nearly to this performant, right? Using this tab method, right? So by learning this, how you can use this tab in practice, right? The basic thing is the basic first thing is you would need this input data, right? The basic input data, at least try to have this maybe 10,000, 20,000 or 30,000 samples of input data and you try to push that and you'll get some responses. For each response, you are implementing a scoring mechanism. Out of this 3 response or 4 response of that particular question or particular input, what is the best scoring one out of that 4 answers, maybe which one you can score more, and based on that you will push that into a particular custom rules, right, which is better if you need it, right? And you apply this particular test time compute, which it undergoes this whole process here for some time to understand it, to find out the better response. And whenever the new input is been given or new instruction is given based on its learning curve, it will try to produce a better one. And this is a continuous process, as we spoke. As the instructions comes in, you will try to iterate it, refine it, and train with the same input data, evolve with the new output options, and score them again to make it more, and better. So it's something like this. As the more input data you have it, the better usually it becomes, same as it. So that's the basic thing, how you will practice in it. This model, I think it came last week, as I said. I felt this is very good. The understanding of the concept is also very good, because since they are trying into the various ways to make their LLMs better, I feel this is also one of the better models, because they have extensive from this classic TAO one, adding this particular test time compute side where you can train it for better time without any label data, which saves lot of time and also the cost. Because as you already know, training the data with the label data is so time consuming, because you need to manually label it for some of the complex tasks. So this one, since it is reasoning model which tries to learn by itself, so it saves you a lot of time. And since you already know, it is having that same inference cost as the normal LLMs process also, this is one of the better thing to know it for as a knowledge purpose. So this is about a paper for this week session. Please let me know if you have any questions or doubts, so that I can explain in detail. And if you like it, please try to like it or subscribe to have this kind of knowledge sessions, so that it will also help me. Thank you all for today for hearing this. See you next week. Bye.